Okay, so this is homework 11, problem 1. And we're given that x of t is a wide-sense stationary real random process whose autocorrelation is periodic. So by that means that r of tau plus a period of t times of constant r is just equal to r of tau. And from that, we want to prove that x caret of t plus kt, where x caret is simply just a linear estimate of x of t x plus kt, is equal to just simply x of t. And so, how are we going to do that? We're going to do that by, first we know that the estimator, or the error, error is equal to just the expected value of x of t plus k big T minus x caret of t plus k big T all squared. And so in order for us to do this problem, we want to find the error such that e is minimized. We want to make this as small as possible. And so because x caret is just a linear approximation of what x is supposed to be, then we can just say it will be equal to ax of t, sorry I didn't write t there, plus b. And so in order to minimize this equation here, we have to just take the derivative of this equation and set it to 0. But we have to be careful because there's two parts of this. There's two unknowns, both a and b. And so in order to solve this, we have to do the derivative with respect to a and then with respect to b. So first, let's just do this with respect to b. And so if we do this with respect to b, so to minimize it, then the derivative of e has to equal 0. So that we have to know. So that means dE dB has to equal 0 and dE dA has to equal 0. Okay. So when we take the derivative, we get the expected value of -2 x of t plus kt big T minus ax t plus b. And so we know what x caret is, so here I just substituted in ax of t plus b for whatever x caret is. And because the expected value, then the -2 would just come out. And because it's equal to 0, this -2 just ends up disappearing anyway. So we get the expected value of x of t plus k big T minus a times x of t minus b. And so we know that this can be split again to the expected value of x of t plus k big T minus a times expected value of x of t minus b, because the expected value of b of constant is simply just that constant, so it's b. And so the b can be moved over to the other side, so the b positive b, so b equal to this value. And we know that the expected value of x of t is going to be equal to the expected value of x of k times t, because this function is periodic. And both of these is going to be equal to just simply the mean here, which we have as n of x. And so by substituting n of x for these two, the expected value of x of t and the expected value of x of t plus k of big T, we get b is equal to n of x minus a times n of x. So now we need to find what a is. So in order to find what a is, we simply just take the derivative of this function, but with respect to a instead of b. So when we do it with respect to a, it's equal to -2 expected value of x of t times this function because of chain rule. So it'll be x of t times x of t plus k big T minus a of x of t minus b. And so this b here, we already know what b is. So now we can substitute in the previous value of b into this function, which is equal to, this is out. But this would be n of x minus a of n of x. And so it ends up being the expected value of this substituted in. Okay. Now we can multiply this x of t across all the components. And so it's the expected value of x of t times x of t plus kt minus a times the expected value of x of t times x of t minus the expected value of x of t times n of x, but n of x is just a constant that can come out, plus the expected value of x of t times this should be positive because the minus distributes out with the b, plus a times n of x times the expected value of x of t. And so we know that the expected value of x of t and the expected value of x of t and is just equal to n of x. And so here we just have n of x times n of x because this is what its expected value of x of t is equal to n of x. Similar here, expected value is n of x, so we get n of x squared plus a times n of x squared. And so we know what this is equal to. This is equal to simply just r of k of t, because the autocorrelation of this is simply just the difference between the two functions. The difference between the two functions here is just the period k of t. So it's r of k of t minus, and here we can factor the a out of these, the first and the last component here. So it'll be a times the expected value of x squared of t minus n of x plus n of x. N of x minus n of x squared here. So this goes out. And so now we have to solve for a. So we can solve for a by moving this a over to the other side to make it positive, and then it'll be r of kt minus nx squared divided by this bracket here. So the expected value of x squared of t minus n of x squared. And so what is just r of kt minus n of x? It's simply just the covariance of k of t. And similarly, the bottom is just simply equal to the correlation of x squared. And so now that we have what both a and b is equal to, okay, we can then find out what x caret will be equal to. So x caret we know is equal to a x of t plus b. So we can substitute in a, and we know as covariance of kt divided by the correlation of x squared times xt, plus b, which is equal to n of x minus a of n of x. And so since we know that the autocorrelation is periodic, then r of tau is going to be equal to r of tau plus kt is equal to r of kt, which can then also be equal to r of 0. So this is all equivalent. So we can substitute r of 0 into a, and so it'll be r of 0 minus n of x squared divided by the expected value of x squared plus t, the expected value of x of t squared minus n of x squared. And then this is equal to just simply just the expected value of x squared of t. Because if there's no difference, it's simply just equal to expected value of x of t times x of t. There's no difference between that. And so as you can see, the numerator and denominator are equivalent. And so this will just equal 1. And so because that equals 1, we know, because a is equal to 1, we know that the covariance of kt has to be equal to 1. And then it'll be x, and then this will be plus n of x minus a of n of x, but since a is equal to 1, this also cancels out to 1. I mean, 1, but the 1 minus 1 is equal to 0. And so then we just get x caret, the linear approximator, is equal to simply just the function x of t. So we proved it.